Okay guys, this is just a quick video to go over the basics that's going to be on the semester review and then ultimately the semester exam. So very first part of the beginning of the year we talked about functions. It's when y is a function of x, the x's cannot repeat. So on a graph like this, we had the idea of a vertical line test. If you could draw a vertical line and it never touched the graph more than once, then yes, this would be a function. So you have that vertical line test as your proof. If you have the actual numbers to look at, you can look at the x's, something like this. You can see that the x's are repeating. So no, x repeats, so it's not a function. Okay, so that was the basic there. Then we moved on to domain and range. Domain was specifically our x values. Range was our y values. Let's practice with this graph that we did up here. So this was what we called a continuous graph. So when we did our domain, it was going to be less than x, less than something. And then for range, it was also going to have y's. Okay, so when I go up here in my domain and range, this is where we did our box. So I'm going to extend every piece of this. Okay, now for x's, I'm looking at left and how far right it's gone. So how far left this has gone, it's going all the way out to the left to 7. So this is going to -7, and this is going all the way to the right 5. So this is going to +5. So I'm going to have from -7 to +5 for my domain. Okay, the other thing here is that there's a closed circle. So that was included. The -7 is included, but the +5 is not. So this, anytime that involves this dot, is going to have the equal to line. So I need to put the equal to line underneath the -7. But the open circle was not including, so we just left that as a less than sign. Okay, range, same thing but with y's. So how far down is the graph going? It's going down to -3, and it's going up to +1. So -3 to +1. And again, that -3 was with that closed circle, so I'm going to put an equal to line underneath that. Okay, so that was domain and range. Then we went into independent and dependent. Independent variables does not rely on anything else. So the big example we always did was time. Time is always independent. It's always moving forward. Dependent variable literally depends on the independent variable. Okay, so y depends on x. All right, so here's an example. My car goes 30 miles in 3 hours. Well, the two variables we have here are miles and hours. So if you can remember that time is always moving forward, time never stops. If you see time in the problem, that is pretty much going to always be your independent. And then depending on how many hours you've been driving, you've gone so many miles, so miles. Okay, that was independent, dependent. A lot of times you need that so you know how to make tables. Okay, so then we started getting into scatter plots. So first thing you want to remember with this is that if you want this R value to show up, you're going to have to go to Mode, scroll down to Stat Diagnostics, and turn that on. Okay, so you want to do that first before you do anything else. And that'll make the R value appear. So anytime you have a table, you can do your Stat Edit, and then you can go back and do Stat Calc 4 for linear regression, and that's going to give you your R value, but only if you've turned the stat diagnostic on. Okay, one thing to talk about with this was R, we called that correlation coefficient. Okay, that was called the correlation coefficient. It was considered strong if it was close to +1 or -1. That meant it was perfectly linear. So strong means it's making a really, really strong, almost perfectly linear function. Weak is when it's close to 0 and when it's all kind of scattered and doesn't really make like a straight line. Okay, so if I have 4 different correlations here, we want to rank them from strongest to weakest. So it doesn't actually matter about the positive, negative. That's just telling us direction. So this 0.97, because it's closest to -1, is actually the strongest. Even though it's negative, it's the strongest, it's closest to 1. So I'm going to put -0.97 as my strongest. The next one down would be the -0.75. That's the closest to -1. Okay, so don't really care about the positive, negative when we're talking about strength. Strength just means closest to 1. So the next one would be 0.56. and then this 0.34 is the closest to 0, so that's going to be the weakest. Okay, so that was all the stuff we did in the basics of functions and x's and y's, and then we finally got into linear. So the parent function for linear was f of x equals x, or just y equals x. It was the most basic function. There was no real slope except for 1. There was no y-intercept. It was just the most basic x. This is an example of what we called direct variation. So if I was to graph this, let me just do a little sketch. Okay, there's no y-intercept, so it's going through the origin, and it's just a slope of positive 1. So this was our parent function. Okay, direct variation is a specific kind of graph, like the parent function, that goes through our origin 0, 0. So whenever you saw things with direct variation or directly proportional, you always knew you had the point 0, 0. And the parent function is just an example of that. Okay, then we got into if I change the parent function by adding in negatives and changing the slope and changing the y-intercept, what happens to the graph? What happens to this parent function graph? If you have a negative slope, that's when we had the reflected graph. So instead of going from positive, it would just turn to negative. Okay, then if we change the slope, if it was a number greater than 1, 2, 3, 4, 5, it got steeper. If it was less than 1, it got less steep. So that would be a fraction. 1/2, 1/3, 2/3, 4/5. Anything less than 1, which is basically a fraction, would be less steep. Okay? Positive and negative y-intercepts. If it is a positive y-intercept, that means the graph went up. So positive meant up. If it was subtracting a number and it got negative, then it just meant the graph was starting at a negative y-intercept, so they just move the parent function down. Okay, so those are the basics there. And then we also had our 3 forms for linear. So slope-intercept was the y equals mx plus b. This is where you had a number for m and for b. This was your slope. This was your y-intercept. Okay, talked about point-slope form. This one looks a little bit more crazy because there's more going on, but you had something in these 3 places. M is still your slope, and then the x1, y1 just represents 1 point on the line. So that's why it's called point slope form, because it gives you a point and it gives you a slope. The thing to remember here is that these negatives were in the formula, so if you saw y plus 2, it was actually a negative 2 for the y value. So just remember it was kind of opposite sign here. Okay, and then standard form was ax plus by equals c, where you had some numbers in for a, b, and c. This one wasn't all that helpful, so we pretty much always said solve for y when you had this notation. Okay. Feel free to pause the video if you've missed anything, but I'm going to go ahead and flip to the back. Okay. So this is more recent, since Thanksgiving. We talked about solutions to systems. Remember, systems of equations is where you just have 2 lines. And so the solution is the point where the 2 lines intersect. So that would be the solution. And this in the calculator is where we did our second trace, number 5. Okay. You also had the option of no solution when they didn't cross, and you had infinitely many solutions when they were the exact same line. If there are 2 inequalities that have been graphed, this is where you start to have the same type of thing, 2 lines, but you have 2 shadings. You have possibilities of having solids and dashed lines and that kind of thing. The solutions lie in the double shaded area. So if I had one line that was shaded above, and then I had another line that was shaded below, the final solutions would be the ones that were in that double shaded area. Okay, then we had our 4 symbols. Anything that had the equal to, so greater than or less than or equal to, those were our solid lines. Anything that didn't was a dashed line, so dashed. Okay, and then going this way, you'll notice they're both greater than signs. That's when we were to shade above. And if there were less than signs, we shade below. All right, and then the very last thing that we just tested on was exponent rules. So just a few quick reminders. There are on the formula chart 0 power, anything raised to the power of 0 equals 1. That's a quick, easy thing to do right away. Negative exponents are not allowed. If you see a negative exponent, we must move it across the fraction to make it a positive exponent. Okay? Formula chart has other rules, but when in doubt, I always say write it out, which means if you have x cubed, you could always just write x times x times x. And then maybe you're combining that with something, and maybe you can cancel, or maybe you can just count how many you have total. So when in doubt, write out all your x's or your variables or whatever you're dealing with. Just a quick example, if you see something like this, t to the power of 1/8 to the power of 4. So basically this whole thing is happening 4 times. It's easiest if you just, and this is on the formula chart, multiply the exponents. So I would do t, and then I would do 1/8 times 4. Do that in your calculator, and you'll get 1/2. Okay, so that's just a quick example. Okay, and the last thing we just did was simplifying radicals. This is where we had, I didn't use this in my class as much, but the dating game, it's a cute little way to remember this, but you had your radicand, that was the thing underneath the radical. We always factored that, so that means 136. What two numbers multiply to 136? You can come up with a few different examples here. I'm going to use 2 and 68. You could do 3 and 34. You have a few options. Just pick two numbers that multiply to 136 and then keep going. So 2 is done. 68 I can do 2 and 34, and then 34 is 2 times 17. 17 is actually a prime number, so I'm going to stop here. Okay, do the same thing with your variables. If I have x to the 5th, that means I have 5 x's. If I have y cubed, that means I have 3 y's. So factor the radicand just means take whatever's under here and break it down into its smallest pieces. And then the big thing in my class I always mentioned is you don't really care about the road you took to get there. You just care about the factors. Okay, circle your pairs. So I have a pair of 2's. I've got a few pairs of x's, and I've got a pair of y's. Okay, here's kind of the cutesy thing I didn't go over through in my class as much. Pairs get to go on a date. It's a dating game. So anytime they have a pair, they get to go out. So I'm going to have a pair of 2's. I'm going to have a pair of x's. So I have an x on the outside. I have another pair of x's, so I have another x. And I have a pair of y's, so I have a y. Singles stay home. Let's call this our home. So singles, we have 2, 17, x, and y. Those are all going to stay inside the house, if you will. Okay? So that's how we can kind of figure out pairs always stayed on the outside, but not 2 times 2. I just put, if I had a pair of 2's, I just put a 2. Okay, I had a pair of x's, so I put an x. Another pair, so another x, and so on. Okay, to finish it off, multiply 2 times x times y. I can rewrite as 2x squared y. And then over here, 2 times 17 is 34, and then xy. Okay, so that's not everything we ever did in this class, but it kind of gets you a quick little reminder of some things. Work on the review, and we will work on that for the next week. All right, that's it.